Good morning, good day, good evening, wherever you are. We are Asgardia, the first in the world history space nation, which was created by Dr. Igor Ashurbeli in 2016. With more than 6 years behind and with clearly set goals, we are running a series of webinars which tell you in great length about various aspects of Asgardia development. If you follow our activities, you know that there have been many webinars about legal aspects and about science. Today, we are continuing our science series. As you know, the main goal of Asgardia is achieving the birth of the first human child in space. That would be a symbol and a major scientific achievement, because the feasibility of childbirth in space will signify the ability of survival of humankind in the universe, which is critically important for the infinite life of biological species, humans. For this purpose, it is necessary to undertake studies in the following three key areas: artificial gravity, protection of space radiation, and human embryology. Today, we will discuss prototype studies which are conducted on Earth in preparation to long-term human space missions. And for this purpose, my two guests today are Professor Floris Vouts, who is the Minister of Science of Asgardia, and Dr. Sergei Ponomarev, who is the Executive Director of Sirius Experiment, which is hosted by the Institute of Biomedical Problems in Moscow. My first question is to Sergei. Tell us a bit more about the Institute. And please share the slides, Marilyn.
Yeah, hello everyone. Could you please go to slide number 2? Slide number 2, yeah, thank you very much. So again, my name is Sergei Ponomarev. I'm the Executive Director of Sirius Project and also the representative of the Institute of Biomedical Problems of the Russian Academy of Science. Just a few words about our institute. So our institute was founded by great academicians, academic Korolev and Keldysh, who were very famous, I think, in the whole world. Korolev was one of the founder of manned space missions, space flights to space, and academician Keldysh. He was the president of Russian Academy of Science at this moment. So, and the main goal for the institute was, and now they remain, is biomedical support of manned space flights and satellites. So we conduct different research activity in gravitational biology, physiology, ecological, extreme, sport aviation, and mountain medicine. So we also conduct experiments in the field of psychology, engineering, and also we explore how, in general, the spaceflight associated factors influence human and animal organism to create new countermeasures for future, first of all, long-term space missions. So I can say that basically we conduct fundamental and applied research in our institute. So, and of course, as I've mentioned, that we conduct experiments in different fields of science, like psychology, physiology, and also we have a lot of experiments that are conducted on Earth, on Earth analogs, to study how the space flight associated factors influence human organism for better understanding the mechanisms and inventing new countermeasures. So I think in brief, that's all about our institute. So we have different analogs like dry immersion, like Sirius facility, like short arm centrifuge, and some others that help us to separate different space flight factors to see the impact of each factor in changes that we observe during real space missions.
Thank you, Sergey. We will talk more about the achievements of the IBMP, but in the meantime, we will focus on everything which has to do with Sirius experiment. First of all, I would ask you to tell us, what does the name Sirius stand for? It is clearly an abbreviation.
Yes, you are absolutely right. It's an abbreviation. It's Scientific International Research in Unique Terrestrial Station. So that is Sirius. So Sirius is a continuation of our isolation missions. If you please go to slide number 6, show us slide number 6. So thank you. At the IBMP, we have conducted a lot of isolation missions, starting from late 16th with a year in the ground by spacecraft, then Hubis, Sphinx, Mars 500, Moon 2015, and now we are focused on Sirius Project. Next slide, please. And next, thank you. So in the Sirius mission, we explore how isolation factors influence human organism, and we conduct research in different areas of science. Like, first of all, it's the main, I think, direction, psychology, then physiology, immunity, microbiology, and biochemistry. For instance, in 8-month mission, we had, which is the previous experiment before 1-year mission, we had more than 80 experiments from 10 countries. The main goal for the isolation missions is to study how the spaceflight associated in isolation missions. Those factors can be seen on slide number 4. Please go to slide number 4. So, yes, thank you. No, yes, that's it. So those factors like monotony, artificial environment. Back, please. Back. Slide number 4. Yes, correct. Thank you. Sensor deprivation, limited resources, hypodynamia, night shifts, influence human organism. And then we also test different new countermeasures like physical exercises, like probiotics and some supplements, human organism, and then we suggest all those potential countermeasures to test it during the real space flight. So isolation is one of the analog models of real space flight factors that helps us to study that I was talking in just a few minutes before.
Here, I would like to note, because I can see that our audience are the people who are not from the space sector, but those who are enthusiastic about space flight. And I would like to suggest that apart from listening to this scientific explanation, you just project it onto yourself. Imagine you are locked up for 1 year in a very fancy apartment. It can be brilliant, it can have 5 bedrooms, all the facilities you want, but still it does not have a window which you could open and breathe fresh air. It does not have a possibility to make a phone call. Yes, because the simulation is not only about physical isolation, but also about the physical aspects of the long-term space flight. And the physics is such that the further you go from the planet Earth, the longer is the distance, obviously. There is a break in the communication line. So if I call you and say hello, you wait for 5 minutes until you hear it, and you say hello back to me, and it's another 5 minutes. So you cannot just have a call. You can exchange emails. They don't go instantly. You can't go on a messenger and chat. It's the same thing. So even the basic things, the connection to your family, connection to your friends, connection to the world, you can't just go online and read the news as they evolve, because it all takes time for physical distance reasons to reach you. That in itself is already a huge psychological deprivation, not to mention sensoric deprivation, which are shown in this chart, because again, you do not have a sense of fresh air, you do not have a view. One of the biggest things psychologists say when they talk about far deep space missions is what is the psychological effect it would have on a person that the Earth is one of the dots in the infinite sky, because we always look from Earth to sky and we see stars. We are huge, they're small. Home planet becomes one of those dots in the sky. If you think deeper into the humanistic aspects of what's presented on this diagram, it's actually mind-boggling. And all these things, before you go into reality, you need to test them. So Sergey, are these experiments which are conducted in Sirius, are they fundamental science or are they applied science?
I would say both. We conduct experiments in the field of fundamental and applied science. And if you please switch to slide number 5. So because there are some different goals for fundamental and applied science, thank you. Thank you very much. So of course, first of all, the main goal for us is to study how the factors influence on human body and different physiological systems. Fundamental and applied research, they are going in parallel. Some data from fundamental research can be then continued in applied research, and then it could go back to fundamental to find out the mechanism. And then both fundamental and applied research, the goal for them, the final goal for them, is to make a very efficient system of countermeasures. So that's why those two directions are conducted in parallel.
Countermeasures are, of course, critically important. Gravity is something which affects everything on Earth. So when you wake up, even if you don't do any sports, the very fact that you get off your bed is working against gravity. When you walk, every step you make is hitting you with minus G on your heel. It helps to train your muscles. It helps to keep your bones dense and in shape. So in microgravity, in the lack of gravity, everything changes. And that's why artificial gravity is needed also for giving birth, for going through pregnancy, because it's only in the gravity conditions that human body is adapted to producing another human body. Professor Floris Woutz has spent his lifetime as a physicist and physiologist in researching effects of spaceflight on human body, and he has performed experiments both in isolation experiments and in spaceflight for many, many years. So, Floris, please tell us what were your key areas of research in Sirius experiments and how is this important for your space research? We can for now switch off sharing screen and we will talk more about different experiences in the last decades and the role of Asgardia in it.
Yes, thank you, Lena. Well, just as a link to what you just previously said, the detection of gravity is apparently a very, very fundamental characteristic of all human species and all actually living species on Earth, by the fact that it has been found that 670 million years ago, that was the date of, let's say, the first detector of gravity. So, I mean, it was long before humans existed. It was at a very, very early stage of living creatures on Earth. And already 670 million years ago, the detection of gravity became apparent as a sensor in everything which moves around on Earth. So it is absolutely fundamental, and particularly the fact that it has been cold, it has been warmed, has been dried, has been wet. So there have been a lot of climate changes and different situations of Earth and of living on Earth. But so we had to adapt to all these different things. But 1G is the most fundamental constant throughout history of Earth. So no wonder, and that's why it is so important to understand very well what is the lack of gravity doing on human behavior, on human immunology, on human reactions, because it definitely is an important contributor to the general health of everything which is living in outer space. So the things which have been important during the Sirius experiment are particularly the ones which are, well, it is a combination of psychology experiment and physiology experiment. On one hand, people move less, for sure. If you have a very small habitat where you can walk around, you just can't go play out a game of tennis or do some bicycling or just running around. So just the fact that you have a limited space means that your body is deprived of movement. So countermeasures have to be put in place to find out, okay, how can we counteract that? So that's one part is just the pure physiology of how humans react in small environments. But on the other hand, there's also a very large psychological characteristic. And the characteristic which is important about personality. How are there changes in personality traits? And the previous experiment of Mars 500, where IBMP has conducted this some years ago, one of the major findings was that, and that was very intriguing to me, was that there was a less and less communication with planet Earth. So the longer the mission lasted, the less was there a need to communicate with planet Earth. And what was quite intriguing was the fact that the crew became reliant on themselves and trusted themselves more than they trusted planet Earth, which is obviously a very interesting finding, because it means that when we install missions to Mars, real missions to Mars, and that will be happening, I think, within the next, let's say, let me be safe, within the next 40 years. But then we have to be sure that we prepare as much as possible to these psychological changes in the human threat. That's why the recent, I don't know about Sirius, well, perhaps Serkin can respond. Is there in Sirius, what type of games are included in for the people to also distract and get a bit of free time? I mean, is it like a PlayStation inside, or is there any games like Monopoly inside, or other games, card games?
Yes, they are. In each experiment, there are different games according to wishes of test subjects. So in one experiment, it was PlayStation, Monopoly, then some other games like, I'm sorry, I do not know how to say it. Maybe it's called Carcassonne.
Yes,
it's a French game. Yes, so like this.
Settlers. Yes.
Yes. So these card games, chess for two players even. Yes, and not only games, I can say, but also they take some movies. They watch some movies, some series during the mission, and during the scientific program, it's very important. They have also some games that are not common, but like group discussions. So there is a subject, and the crew have to answer some questions to act like a unite crew to provide an answer how to, like, for example, build a new city on a planet. From which steps would you start? So then how to solve some problems with this city, what you expect, what hazards do you expect, and also a lot of problems are focused on human psychology, as you mentioned, because it's from our opinion, from our point of view, it's, I think, human being is the most vulnerable element during the space flight. So the psychological status, the performance of course, is of extreme importance to conduct the real space mission. So that's why we have also some of nominal events, of nominal situations. They are like also could be like games, because the crew need to find some problems and fix them with equipment, starting from computers and then to space. Some space like features of and elements of the spacecraft, which we also simulate in NEC facility, and also could be like real one to find real just cords and to fix them. And also there are some simulated computer games that helps to simulate some of nominal events. So we have really a lot of activities in this area.
Well, one of the experiments which I know is that the fact that they evaluate the voice in order to find out if you say through the radio, even taking care of the delay, how is everything? Everything fine? And then, okay, 5 minutes later, the response comes, yes, I'm feeling fine, or yes, I'm feeling fine.
Correct.
So the information which is, so the words is one part of the message, but if you don't have energy anymore and you say, yeah, everything is fine, it's a totally different story. So the keeping up of appearances is important, because yes, you want to be sure that you're telling the right thing, but on the other hand, if you're just exhausted because you had bad sleep and there had been some mishaps and there has been some extended crew time because there was no electricity for a certain moment, or I don't know what, then you still have to you have to take care of this thing. So that's one of the experiments, is indeed definitely just looking at the voice, well, hearing the voice as an additional variable which can explain how the crew is performing. Go.
Yes, you're absolutely right. I totally agree with you. And also I'd like to add that we also have a special program to analyze voice, but also have some and develop some new equipment to analyze the face expression. Maybe you remember a very famous series, Lie to Me. So of course you might say everything is okay and will be very straight, and you can also say everything is okay with a smile. And that also will be fixed and will be caged by the program. Some psychological tests, as you assume. So some test subjects could cheat and answer that everything is okay, and psychologists could have just wrong information. But voice recording and then analyzing it with a special program, as well as the face analysis, it provides, I think, a very objective information about the psychological status of the test subjects.
By the way, the Mars 500 experiment also yielded that there is a lot of homesickness eventually coming. So I was wondering, is the next Sirius mission of 1 year, will it introduce countermeasures, even if it would be just like having more pictures of home people and of family and friends? Is that something is that lesson learned from the previous experiment, or how is the current experiment taking care of this? Well, normal, but still, I mean, you would say they're all well trained, they're all very well selected, but still homesickness appeared to be an issue. So how is it going to be taken care of?
We are thinking, first of all, in 1 year mission, we are thinking to have a virtual windows. First of all, we can have some illuminators, and they can look to the virtual illuminators and see some stars, maybe moon surface. Then we have some photos, and we send to the crew photos of real life from Earth. Very often the psychological support is being asked to provide some pictures of some holidays. And in the 8-month mission, what I know that there were requests from the crew to send them pictures of snow, of rain, of sun, because they really miss all those simple things that we are sometimes do not pay attention on. So the sun, yes, good, but when you stay for several months in the isolation, you really like the sun, the wind. You want to see the snow. You want to make, like, an angel in the snow. You want to swim, and this is the question, of course, and they are asking to provide them, and we are providing them all those pictures of beautiful cities and beautiful natural landscapes. And also the first time in the 8-month mission, and as well as in 1 year mission, we want to implement the virtual means of countermeasure that will have like, a virtual room. You will put on special spectacles in which helmet of virtual reality, and there you will be able to travel to some mountains like to Everest. You can see the beach, the ocean, or whenever you want. So that's also the sort of countermeasures, and we will test different screens, different pictures, and see which pictures will be of the most importance to the crew. Also, we want to test some virtual fishing equipment and some other to test how it would help our test subjects overcome all hardships that are connected with the isolation.
That sounds like fun. Huh? It's all of a sudden being in isolation is much more fun than just living your regular life and commuting to work every day.
Well, to be honest, I disagree with you. For the first 2 or 3 weeks, I would agree. Yes, they have the timeline. Everything is predictable. They have their some tasks to do, but then in a several months, they really feel very homesick, I can say. Then, of course, they miss their friends, families, and that's my opinion. Virtual reality could only just help to overcome some hardships, but they will never, of course, never, I would say, be like real friends, real nature landscape, and so on. So that's like only a sort of countermeasure.
Of course.
Yes. So that's why I disagree.
So
it's a supplementary material, nothing more.
Yeah, it was more of a joke, but is there actually some psychological compatibility going on, or selection for psychological compatibility parameters when the crew is being formed? How free are you? How big is the scope? How many people do you choose from? And if you have this luxury, not only to evaluate each individual for their skill and competences, but also how well they match, because they basically become a family for 1 year. That's a lot. Some people stay married less than that.
It's a really very good question. That's one of the issues that we are trying to solve in our isolation missions. So first of all, starting from the first part, I would say that we have a number of applications, starting from, I think, several hundreds of applications. Then our special team, psychologist team, they look into the biography and they select those candidates who meet all those criteria. Those criteria like good health, willing to spend 1 year in isolation, because sometimes people do not aware that they have to spend all the time 24/7 in the isolation. They think that they could do some stuff, then get out of the isolation, do their job, then go back, and so on. Also, some people think that they could work distantly using internet and just communicate with their friends using computer and other devices, electronic devices. But that's not true. And when we explain to the candidates, they said, oh, that's good, of course, but we are not able to drop our job, to cancel everything now that we want to do. And that's why we have approximately 50 good candidates which start the preparation to the mission, from medical, psychological examination, and afterwards we have approximately finally approximately I would say, 15 candidates, from which we select 6 prime and 6 backups. 6 crew members, it's the exact amount of test subjects. So why only 6? First, because we anticipate that for the long-term space journey, will go not more than 6 crew members because of the lack of space in the spacecraft. And then, so our also NEC facility is designed to take aboard approximately 6 crew members. So that's why it was chosen like 6. So, and then we have also 6 backups, and with 12 crew members, we start our activity. Then the question of the matches. That's very good because also this, of course, question refers to the real cosmonauts. We want to do so. We at the final stage in our isolation missions, we ask the opinion of different tech subjects with whom you want to go to the isolation. And they say that I want to go with Mr. Smith, for instance, and I want to go with Mr. Johnson. So, and of course, we have their opinion. Also, we have some tests. We have a special psychologist who comes to the pre-mission activities like baseline data collection, like training. We have some team buildings, like we organize in Marfas 500. We organized a survival in nature. In Sirius, we think in 1 year mission before this, I think we will do something like that. Also, we organize some excursions, like to Museum of Cosmonautics, or to very beautiful ancient palaces from the 19th, 18th century. And the psychologist also observe their behavior and make his conclusion about the team, who are working in team before the mission, and of course he gives his opinion before the final decision is made.
And this is for me particularly interesting because I know that everybody is somehow under the impression that the crews for the International Space Station also undergo the selection taking into account compatibility of the people. But as far as I know, this is pretty much an urban legend because
yes,
so many
right.
political factors are playing into this.
Yeah, you're absolutely right. It's a legend. Sometimes crew members matches, sometimes not. But I can say that a lot of crew members, I think 99 and 9 in period, are very good professionals. They could overcome a lot of hardships that are connected with inter-individual interaction. That's very important because when you stay for some time with a man in a very closed chamber, some of those things that are not so very important in common life becomes very important in the facility, and it could really freak you out, unfortunately. But all our cosmonauts and astronauts, they are really professionals, and they cope with that very well. If we talk about the long duration space missions, and of course, if we talk about the commercial cosmonautics, people will not so be good prepared like cosmonauts. And I think on this stage, we need to implement the system of matching between the crew members, especially when we talk about the commercial space flight. Well, we will have, I think, more people than we have now aboard of the International Space Station, because it will be like moon villages, Mars villages. And at this stage, of course, I think we should pay attention in this aspect. And in our isolation mission, we are trying to include different criteria to develop different tests and different team buildings situations, games, again, which Floris mentioned. Games are very important. You can see how people act in the game. Of course, it must be a group game. So we are developing new tests, new measures, how to evaluate the group matching.
Floris, I see you also want to add something to this.
Yeah, I was told by an astronaut recently that they had a bunch of tourists in the ISS, and that there was a bit of, let's say, some strains between the professional astronauts and cosmonauts. And then the tourists, they just were there for not doing anything regarding experiments. So they were sometimes really flying in the way, and they prevented the crew to do their job. But okay, fair enough, that because it's not a big room there, there's a few places. But then at a certain moment, there was sort of like an emergency situation. And so they had to act upon the emergency situation. And the tourists, they continued what they were doing. They didn't take care of, they didn't listen to the fact that, listen, guys, there's an issue, we have to do this. And so that is, I think in the selection of indeed people going into the selection, the isolation experiments is absolutely essential. And the same will have happened for the people going to Mars eventually. They have to be selected very carefully. And I can add to that I had in the past, since 2007, the tremendous honor and pleasure to test 44 cosmonauts and astronauts going to space and coming back. And we tested their equilibrium system. And apparently, those who went like several times in space, the more they went into space, the more robust was their detection of gravity, which is very important because it means that when they are setting a foot on Mars or Moon, or particularly Mars, they will much quicker detect this level of gravity, which is smaller than on Earth, it's 0.38 G. So that means that when we want to send people as humanity to Mars, it is essential that we use people, or that we ask people who have been already at least twice or even 3 times in space for quite some period, that they go, rather than fresh young people, which may perhaps have a very good advantage physiological wise, but it takes quite some experience to go into space and to cope with what space does. So I think for space flight, the older you are, the better you are, to a certain extent. I mean, I'm not sure what is the limit of this, but because on Earth, gravity is indeed doing its tricks and makes people look worse the older they get, because there is less of elastin and collagen keeping your face in a very strained situation and shape. But going to space is a different ballgame, and their experience and profound experience, I think, will be essential. And if the psychologists are choosing people, I think, I'm not sure, but perhaps we should, and that was actually my question to Sergey, what is the background of the people who are being selected now, and is there a psychologist among them?
The professional background, we apply the same as we want to see them on the ISS. So those people have the engineering education, those the engineering technical education or medical education. Some of them had some military experience. We prefer to include to the space to our space analog all those test subjects who really willing to participate and have some experience in the area of space industry. So those criteria were chosen for the Sirius project. Unfortunately, we didn't have a professional psychologist inside the crew. We had people who had some very common to psychological education, like psychiatric education, but not exactly psychology education. So we had medical doctors with a psychiatric background, but no psychologists.
I'm not sure if I may allow to say that, but I think indeed the psychology is very important, but psychiatrists presumably will will be able to address even more efficiently possible deteriorations and aberrations, or let's say deterrent habits in crew, because of the more systematic and what is it, the methodology behind how the brain is functioning or dysfunctioning given certain conditions. But okay, I mean, I know that there will be never aberrant situations, but I do know that many years ago I asked a cosmonaut, what is the biggest challenge to go to Mars? And he responded to me, to my great disbelief, it was not about, okay, we have to make the rockets, or we have to foresee the energy or the life support systems or anything else, but he said, it's the human mind. Just realizing that you're walking there on the Mars surface as a representative of humanity, that will be mind-boggling. That's what also Lena said in the beginning. And this mind-boggling thing, I think we have really, I think that's the strength of the experiments which you are now conducting with this series. It's to uncover this mind-boggling impact. And if you can approach it and describe it with parameters, then you can tackle it, and you can take the precautions and the countermeasures which prevent people of going mad, actually. Well, not going mad, but I think it will be very strenuous just to realize.
I would like to comment to your earlier conversation that, as far as I know, the oldest person so far to have flown professionally is John Glenn, who at the age of 78 reflown shuttle. But if we talk about the new developments, I believe William Shatner, who is Captain Kirk, is older than that, and he's flown not so long ago as a passenger on a recent commercial suborbital flight. And he still talks about it, and it seems to work. So as long as you are in a decent health, actually the age is not a limit at all, and the sky is not a limit. So we're living in amazing times in this sense. In terms of you talking about psychiatrists, as a layman who is not planning to go to space, I have to say, I would be horrified by being locked up, not just only for 1 year, but for 1 year with a psychiatrist. So I'm not sure it's a benefit, I have to say, but okay, you know better, you are the medical doctors and the scientists here. We have an interesting comment from Dan Profir, who is our Minister of Youth and Education, actually, and he's watching us here in the audience. He's mentioning something which happened only a few days ago. A Spanish researcher completed her 500 days isolation mission. She is an athlete, and she was alone in a cave. And at some point, she also has let go of the perception of time. So I'm not sure what it actually means, but I suppose that she just stopped looking at the clock and just lived her natural biological rhythms. So she's an elite sportswoman, mountaineer, and a climber, and she's been monitored in a project called Time Wave. So indeed, amazing things happen all over the world. IBMP has a legacy and history of conducting space research, isolation research rather, for the space research purposes. And that is why Asgardia has a long-term partnership with IBMP, and we have already completed one experiment with Asgardia resident, Dr. Victoria Kirichenko, who in the previous 8 months isolation study Sirius, amongst other duties, including medical doctor on board, conducted 3 experiments related to female health in space. Because clearly, when we talk about giving birth to a first human child in space, it's critically important that a female who carries that child, should that happen in the female body and not in some artificial incubator that we don't know yet, of course. We are some decades away from this possibly. But nevertheless, female body as a pregnancy-bearing mother, as a nursing mother, it's extremely important. So Asgardia is collaborating with IBMP in all the areas of human physiology, which relate to preparation to very long human space flights. Sergey, if you could tell us a couple of words, what are the results of that mission, 8 months Sirius experiments, so our viewers, our listeners have a better picture and understanding why and how Asgardia and IBMP continue this long-term research.
So I would like to say just some words about the main results, which refers first of all to Asgardia. First of all, I'd like to say that despite of a lot of isolation missions, we still find some different fundamental aspects of those studies in different areas, not only psychology, but also physiology. And I am also an immunological scientist. I'm the head of the laboratory of immune system physiology, and we study how the isolation factors influence on human immunity. So despite of a lot of studies, we have very small group of test subjects. Even if we add some cosmonauts, but there is a big problem with cosmonauts because we are limited in equipment. We can see some parameters online on the board of the ISS. We're trying to develop new equipment for the board, but we still lack the scientific equipment aboard of the ISS. So, but we have them in our facility or outside because we can collect blood and immediately proceed with this blood and analyze it using the modern devices to see how it influences on different parameters. So what was our surprise that in 8-month mission, if we talk about the immunity, we observed the reduction of some humoral parts of immunity like immunoglobulins. So it's very important molecules that defends human organs from bacteria, viruses, and so. So the general level of immunoglobulins dropped. We didn't observe that in previous mission. If we talk about pregnancy and not only and the labor, of course, and the lack of some immunoglobulins as well as some immune cells that are responsible for immune response. So it's a risk of prolonged wound healing. So that's very important result because we have a risk, the immune risk, that if we have a childbirth aboard of the ISS, we could fancy the situation in which some process of healing after the labor, so it will be prolonged, or it could lead to some unfortunately disaster situations like sepsis and so on. So that's the result. Also, we observed changes in microflora, in protective microflora that also helps to overcome some challenges with the reactivation of pathogenic microflora. So also what we've noticed in isolation mission in this study, it was also a very big surprise for us. We didn't publish the results, but we are going to do this. That you know that there is no microgravity in the isolation. So we just have hyperdynamia and nothing more. But even in those conditions, we observe the bone loss in the isolation. So it was a really very, very surprising for all of us. It was like a wow result from this mission. And so we have to cope all those hazards, all those risks to make childbirth aboard of the ISS very safety. Also, we should develop a lot of new equipment, a lot of devices that could help us in absolutely autonomic conditions, because we will not have a team of professional doctors aboard the space station. It's a very challengeable project. And I think we need to use some new devices and to start the preparation on Earth, because here on Earth, if something will go wrong, we can immediately evacuate the crew member and send it to the professional hospital. Aboard the space station or Moon or Mars planet, we will not have this possibility, unfortunately. That's why we should develop all those countermeasures and new surgery devices, new methods, we're using telemedicine, of course, support different models of it, different trainers, and so on.
I think it may be important for the audience to realize that the challenge of spaceflight is so unique in the fact that there are a lot of stresses at the same time. I compare it typically with if you go to a hospital, then there is a department or there's an area where people are being treated for problems with the heart. And there's another area, another ward where people are with kidney problems are treated. And there is another area where people with neurological disorders or muscle disorders are being treated. Going to space means that actually you have cardiovascular loads, you have bone loss, you have muscle loss. The brain is being affected, and it all happens in the very same person. And that's what makes spaceflight and human space physiology so tremendously complicated, because you can imagine that you find a solution for one problem, for instance, weightlifting. You could say like ARED is a device in the ISS where people are, it's equivalent to weightlifting on Earth. But we, with our team in collaboration with IMBP, have recently found that weightlifting may be bad for the brain. So it can be good for one thing, for muscle and bone, but perhaps be really, really deleterious for other parts in the body. And that's why it is so essential to combine all these different studies, like the Sirius study, together with other studies being conducted in different situations, bed rest study, dry immersion, isolation in Antarctica, and other studies, parabolic flight on Earth, where you can have the luxury of having a bit more people, although it's not so, I mean, it's not like a tenfold, but at least more people than in the ISS, to put this jigsaw together, this big puzzle, and use information from the immunology experiments and psychology experiments and voice, etc., from all these different studies and put it together. And that's the magnificent thing of space research and research as together. The truth is every day building up, and things which were true yesterday may become not entirely true today, because we just know more about the real physiological and the real nature of what happens. And that's what makes actually this research so interesting and intriguing day by day, to try to find out what is happening.
Okay, I'll take one more question from the audience. Do participants of isolation experiments have significantly more chances to be chosen for actual space missions? I would say it's not necessarily significantly more chances, because first of all, if we're talking about the missions to the International Space Stations, those are chosen from the 5 partner agencies, which are Roscosmos, NASA, European Space Agency, Canadian Space Agency, CSA, and Japanese Space Agency, JAXA. Each of them has their share of resources, according to which they're entitled, amongst other things, to fly their astronauts and cosmonauts to space. So first of all, you need to be the national of one of those agencies. Then you need to undergo the astronaut cosmonaut selection procedure announced by the respective agency, and that happens every few years. It doesn't happen continuously. So you can't just go and apply for a job of an astronaut. You need to undergo a selection, and once you have undergone the selection, then you are selected as a trainee cosmonaut, as a candidate cosmonaut. Then after the initial series of studies, you are qualified as a cosmonaut, and only then you have a chance to be assigned to a program. So first of all, if you are from a country which does not participate to the International Space Station program, you do not have a chance, unfortunately, to be selected, because you do not belong to the nations which government is funding it. That's actually one of the advantages of Asgardia. It's looking to open space research and make results of the space research available equally to the entire humanity. I am answering, however, about the current situation, the current flights to the ISS, which are going to run for at least 5 years, and the nowadays published planning. So I would say that if you are a Russian citizen and you are working with Roscosmos, then maybe you have more chances that I can't judge, or maybe Sergei can comment on this. But in general terms, I would say no.
Yes, you are.
Go ahead, Sergei.
Thank you very much. Sorry for interruption. Just a few words in small addition. Yeah, Elena, you're absolutely right. But I would like to say that the experience that people could have in the isolation mission helps to understand better the situation aboard of the ISS. And I can refer to Anna Kikina's interview. She completed her space flight, and her interview, she said that during the isolation she participated in Sirius Project. She had an experience that helped her to better understand the conditions of the ISS. So that's a good experience was for her.
Absolutely.
On top of that, I think it may be interesting to add, because it's a question which many people ask, what do I have to do to become an astronaut? Or what do I have to study? I think what is important is having a combined studies, in the sense that if you're a medical doctor, but on the same hand, an engineer, or if you're a pilot and an engineer, or if you're like a geologist and together also a biologist. So if you have several diplomas, several educations at the same time, I think that is a prerequisite, because we can't send an army to, I mean, like a whole university to Mars. We have to send just a few people, but then it's important that they combine as much knowledge as possible to cope with all the problems. And in that point of view, I think if you have experience in isolation studies, and suppose, let's say, you have two equal subjects, candidates, both from the same nation, so they're perfectly equal regarding education, but one of them had indeed an isolation study participated, which, and this was indeed beneficial in the sense that the person came healthy out of that and was not doing very strange things at the end. Then that was also proof for those who may select this person, like, okay, this person, he or she survived already like 500 days of isolation, everything went well. So that's a guarantee for those who choose. So it's a combination of many factors at the same time. So it is not a direct prerequisite, but I think it will add
amongst many other parameters which are considered.
Yes.
Absolutely. Okay, we will take very quickly another two questions. We're coming to an end of our 1 hour seminar. So I guess that one of the most important points for a good mental health, for good isolation, is to have a productive timetable. Sergei, maybe if you can quickly comment to that. I believe you already spoke about this.
Yes, absolutely right. The timetable is very good. And if you stick to the timeline, so of the experiment, that helps you to overcome some hardships. But you have some leisure time. You have, in spite of this situation, even with a strict timetable, you have your inner thoughts that are with you all the time. And in this regard, of course, a strict timeline would help you, but not for 100%.
Okay, so it's very important also to have self-discipline and also not to abandon your own hobbies. So you're mentally remaining the same person, the same interested, the same committed person. Next question. We speak about pregnancy. This implies love sexual relationship between members of the crew. Are there any scientific studies about it, or is it still within the private area? Doctors, any comments? Floris?
Well, I know there are a few studies that have been conducted, particularly also in the Antarctica isolation studies. And very, very reluctantly, people start taking part in questionnaires about sexual habits and about interrelationship, etc. Obviously, it's very complicated and indeed a very private area, but we also have to face reality. A human being is a human being. And if he or she is okay with herself or himself, in the total of everything, it will be also a good condition to survive different conditions. So I think that more and more research is going into that branch, but it is just step by step. But things are happening, taking into account privacy, taking into account anonymous questionnaires, and if that is being taken care of, then things can go on.
Sergey, anything you would like to add?
Just a very small comment. I think we still lack the research of reproductive systems of human, both male and female, and I think we should more focus on those systems.
Yeah, it's also what I wanted to say, because even on Earth now, there are plenty of methods of achieving pregnancy as the cell combination. Therefore, I believe that when we talk about pregnancy in space, we are talking, first of all, about the scientific aspect of creating an embryo and gestation. So while love and romance are pertinent to human nature, and we always have to take this into account, in the psychological aspects of isolated missions and limited group of people, nevertheless, my perception is such that we are talking, first of all, about the technicality of dealing with the biological samples. And who knows, maybe artificial womb ultimately is much more efficient way of protecting an embryo and achieving its successful growth. So it's a very interesting for humans to talk about humans. We're here still talking, first of all, about the optimal setup of a scientific activity. Next question, do you believe that it is better to send humans as seeds into space for colonization of planets and deep space, rather than to send humans on deep space missions that might reach these planets sometimes in the future, perhaps? I will keep this question to myself. I'm not sure I entirely understand it, but what I would like to say is that this to me sounds a little bit like science fiction and something futuristic, because I can only assume to reach planets in the future, it's going into hibernation, deep sleep, freezing, defrosting, waking up. I can't see anything else in this. So we are at the moment not talking about any experimentations on humans in the area which is not properly researched. Experimentation on humans is safe, first of all, in line with all the international regulations. And we are not talking about any one-way missions. This is also against humanistic values of the 21st century.
If I may add to that, Lena, I'm organizing, as you may know, in July, a big conference in Antwerp of the International Society of Gravitational Physiology. I'm hosting this conference, and there are a couple of sessions which are devoted to torpor, to winter sleep, because that is an area within the agencies which is being studied seriously, because we can really learn from hibernation in animals and to see what are the possibilities in the long term for humans. But obviously it has all to be within the framework of ethical conduct, etc. But it is definitely a topic. And during the first ASIC conference, the Asgardia Space and Investment Conference, which took place in Darmstadt some years ago, there was also a session about this torpor. And actually, for me, it was the first time I heard about hibernation being studied for future spaceflight. So it is definitely not only about, it is a topic of research.
Okay, I'm taking one last question. We already ran over the scheduled time, but it's fun and it's difficult to let go. Do participants follow the 24-hour day cycle, or is there an alteration to the wake-sleep routine? They follow 24.
Yeah, also there, if I may add, so this experiment last week from this Spanish sports woman, apparently the sleep-night cycle started to become 48 hours instead of 24. So because she was deprived of time, of knowledge of day and night, eventually the natural biorhythm evolved to become much longer, actually almost double of the current cycle of 24 hours. So it is something which is absolutely very interesting to find out and to know. And eventually when people go to Mars, and the question may rise, do we keep the day 24 hour period of Mother Earth, or should we, or of Earth, sorry, or should we, or should we adapt to a biorhythm which is apparently intrinsically built in humans, which may be a different time than 24 hours?
But then, of course, if it's just one person who experienced this statistically is totally insignificant. So before we consider to say that there is a different biorhythm intrinsically built in humans, how many people, Professor Wout, do we have to research to extrapolate it on the human population?
Absolutely, you're totally right, and for sure, n equals one doesn't mean anything. But on the other hand, if you would have told me in the beginning, like, okay, that is, it will be 48 hours even in one single person, I would say, well, this is really bizarre. So it opens, let's say, it paves a way to look into
Absolutely.
further.
But my question was genuine. It was not mocking. It was honest question. How many people need to undergo the research, and of which how many need to show consistent results for this to be a conclusive evidence?
That depends on, and now you're addressing the biostatistician in me slightly, is that depends on the variability. So you would start, for instance, with 6 people. I mean, you could use Sirius as a, okay, Sirius sequel, the third one. You could use that as a incubator and find out, okay, if in 6 people, what is the variation? If the variation in these 6 people is that one is going to a sleep night cycle of 8 hours and the other is going to 48 hours, then it's a very complicated situation. But suppose all are evolving to like something around 48 hours, then you would need another bunch of 6 people. But if that appears to be like a built-in our genetic material, then you don't need like 500 people. You just can do it with you should calculate the significant level and based on the variation of the observations which you make.
Okay, so me being not scientist, what I understood that we need to study at least close to 10 people without them influencing each other. So we need at least 10 caves and 10 top athletes to see if they make sense, because of course being locked up in even in a fancy living room with the psychiatrist, I believe the very fact that people influence each other would make a difference how they would dare to say what's their natural rhythm, because it's part of socialization to have breakfast together, to have dinner together, to undertake scheduled fun activities together, as we have now discussed at length. Psychological comfort and psychological comforting of each other makes a big difference for the team spirit and for the efficiency of the operations. So at the same time, letting them run individual day cycles is totally counterproductive to having them merge as a team, bond as a team. So this is actually mutually exclusive. So while what you're saying makes perfect sense, these are 2 separate experiments and 2 separate facilities with absolutely different sets of tasks. Fascinating, never thought of that before. Sergey, would you like to comment to that also?
No, I think everything was said. I have nothing to say that.
Well, I can add one more thing, if I may. A very intriguing experiment by American colleagues who who investigated the day-night cycles in rats, and they put them on a centrifuge. And so it still was the same day-night rhythm as on Earth, but once they were deprived of their vestibular system, so when the equilibrium system is not capable of detecting gravity anymore, then they deteriorated also from this day-night cycle. So the gravity system, our gravity sensor in our brain is measuring and determining the day-night 24 cycle. So which actually means if you would go into microgravity, then indeed it may very well be something else. And if that would fit more with the human nature in a deprived situation of gravity, it could increase the significant the efficiency of this crew. So it's an intriguing thing to put things to combine things together and put this puzzle together.
Absolutely.
And, yes, and also I think it's very important to understand if this works also with people, because those results were gained on rats. So
Yes.
there are some difference sometimes between animals and human beings. That's why we conduct the experiments with people, with participation of people, to find out all the results that we can't find or extrapolate on animals.
So what I'm hearing in this, dear viewers who are considering to become subjects and objects of space research, first they will deprive you of sleep, and then they will rotate you on a centrifuge. So think twice. So Flores, did I interrupt you?
No. It's well, we need artificial gravity, and we need more things to study. But that, I think that's the nice combination of what Asgardia is also doing. It's really is putting an emphasis on we need to study, and we need to search and do the research which is necessary to survive and to be happy in our future in space.
Yes, you're absolutely right. And in my opinion, the problem of artificial gravity is very complicated. To be honest, sometimes I'm a bit skeptic if we need to use aboard the ISS or aboard the spacecraft which would fly to Mars the short-arm centrifuge. Because on the one hand, we could just countermeasure, have a very good countermeasure against microgravity. But on the other hand, if we adaptate people to the spaceflight conditions and then back to Earth conditions, back to spaceflight, and so maybe those adaptation and readaptation could have a very bad impact on human performance and different physiological systems. But we need to conduct a lot of experiments to find out. That's why this question is still open and very complicated, in my opinion.
I think, Sergey, that variation is a key for happiness and boredom not. So I think if you do the variation, what we need as humans, we need different stimuli. If you put people in a room where you don't hear anything, you will imagine sounds to hear. If you put people in total blindness, they start seeing things. So we need inputs. So I think variation in our inputs maybe just a little bit better than not. But okay, that's a long discussion, which
Yes.
we can have another session about artificial gravity.
That would be actually very interesting, because while today we discussed the practical aspects and the ideological aspects and the scientific aspects, why long-term isolation study is performed and why Asgardia, with its mission to achieve birth of the first human child in space, is cooperating as partners of Institute of Biomedical Problems. It would be very interesting to continue to go into more details, and this is an excellent conclusion actually from today's session. Any closing remarks, colleagues?
Totally happy.
No, well done. Okay, we have overrun by a quarter of an hour the scheduled time. Thank you very much, dear panelists, for taking extra time to stick with the very interesting questions from our audience. Today, we have covered the question of long-term isolation studies, which are happening in the Institute of Biomedical Problems in Moscow, where Asgardia, the space nation, is a partner. And the panelists today were Dr. Sergey Ponomarev, who is the executive director of the Sirius experiment of the Institute of Biomedical Problems in Moscow, and Professor Dr. Floris Vautz, who is a professor at Antwerp University and the Minister of Science of Asgardia. I am Lena Devina, Prime Minister of Asgardia. Visit us at asgardia.space, join us. And by the way, we have parliament elections ongoing. It's still your chance to apply. Thank you, and we see you soon.